Chris, thanks very much. This is BBC Radio 4. Now, Professor Richard Dawson is the last scientist this week, reflecting on his personal experiences in climate change and me.
When I chose to read engineering at university, I was looking forward to understanding the practicalities of building and designing things. Impressive bridges, buildings, perhaps the most visible manifestation of civil engineering. The Second Severn crossing was probably the most iconic project at the time, but I was privileged to spend some time working on the Wimbledon No. 1 court construction during my student years. Never though could I imagine back then that I'd be working on projects such as moving sand on Lincolnshire beaches and examining how flooding affects emergency services. It never crossed my mind how broadly I'd have to think as a civil engineer and how important we are to tackling many of society's greatest challenges, including climate change. My own work as an engineer looks at understanding the impacts of extreme weather events. It considers how to construct buildings so that our cities are more resilient to floods, droughts and heat waves. We are in the business of helping society reduce greenhouse gases and other pollution from transport, energy, water and waste infrastructure. I went to university a few years after the Rio Earth Summit of 1992. During my degree, I don't recall learning about climate change. It wasn't until the end of my 4 years that I was introduced to the concept of environmental sustainability. Yet the methods developed to consider sustainability back then were not sophisticated and felt like more of a bolt-on rather than embedded in the thinking of design from the outset of a project. At the time, though, I gave this no further thought, and to be honest, I'd lost my fire for the subject and was seriously considering other career options. Perhaps the first watershed moment in my own career, and certainly what rejuvenated my passion for civil engineering, was when I started my undergraduate dissertation project, which looked at coastal erosion in Lincolnshire. The coast there is vulnerable to erosion following tidal surges, storms and heavy seas. Behind the coast, near the seaside towns of Skegness and Mablethorpe, the land is flat and many homes and businesses are at risk of flooding, despite the sea defences and beaches. By replenishing sand on the beach, we can stop the waves reaching the main sea defences. This increases the lifespan of the defences and reduces the risk of flooding to 30,000 or so properties. We developed an approach to identify when and how much sand would be needed to manage the risk of flooding. Statistically, we might be able to say how frequently the most destructive waves will crash against our beach and coastal defences, but we couldn't say whether that would be tomorrow or 50 years from now. Moreover, unlike the properties of many engineering materials which behave reasonably consistently, the response of beaches, cliffs and coastal defences is unpredictable. I had had my first formal introduction to uncertainty, an issue at the very heart of responding to climate change. My project supervisor back then was Professor Jim Hall, now Director of the Environmental Change Institute at Oxford University, but then at the start of his academic career. His enthusiasm for understanding the implications of these uncertainties in this and other civil engineering problems inspired me to stay on and become his first PhD student. My PhD looked at flood defence infrastructure, in particular trying to understand how and when a flood defence might fail. Again, uncertainty was at the very heart of this. How do you assess the likelihood a flood defence will fail when you can't see inside it and when you can't predict exactly how big the next flood will be? My research developed an approach to make best use of limited observations about the condition of flood infrastructure and thereby provide engineers with lower and upper limits of its strength. It is difficult to imagine now, but climate change was not a driver behind this work. Having recently reread my PhD, I see that it does get a brief mention, but it was very much a sideshow. Without a doubt, the most important shift in my thinking came from the second project I started after my PhD. This was work with the Tyndall Centre for Climate Change, a consortium of UK universities set up in 2000 to bring together researchers from the social, natural, physical sciences, and a few civil engineers as well. The centre was named after British scientist John Tyndall, who proved the greenhouse effect. I believe that the Tyndall Centre was the first of its kind, a genuinely pioneering multidisciplinary research centre, and an approach that other countries and universities around the world have sought to replicate. I still vividly recollect my first Tyndall Centre assembly, the annual gathering of all affiliated researchers. The breadth of subject backgrounds and diversity of perspectives represented by attendees were unlike anything I had come across before. I had previously been in some multidisciplinary meetings, and they were typically hard work. Yet here the atmosphere was fun and friendly. Despite the challenges of working across different subjects, everyone was passionate about tackling climate change. The people I met through Tyndall, are among the most inspirational I've worked with. If I do have an aha moment, it was probably sometime during the first year that I worked in the Tyndall Centre. My interest in climate change caught light. I rapidly became aware of how significant the impacts associated with human activities, greenhouse gas emissions, consumption of resources, and rapid population growth had become. My first project in the Tyndall Centre was back on the east coast of England. Some of the cliffs along the North Sea coast of Norfolk are slowly disappearing. My work was focused on erosion in the village of Haysborough and flooding in the Norfolk Broads. In 1959, sea defences were built to slow the erosion of the beach and cliffs, but at the turn of the century, changes to government policy suddenly meant that coastal protection in Haysborough was no longer fundable from central government. The sea defences at Haysborough were to be allowed to gradually fail, which would ultimately condemn the village to the sea. This had understandably created significant local tension. The work we did showed how, as the cliff eroded, the sediment that this released moved along the shore and provided natural beach protection to people living in the Norfolk Broads floodplain many kilometres away. Climate change predictions show that as oceans warm, they expand, causing sea levels to rise. In the context of this rising sea level, we assessed a number of different scenarios and trade-offs between different engineering choices along 72 kilometres of the east coast of England. Social scientists from the Tyndall Centre then worked with communities, government and others to explore the implications of different choices and look for more sustainable adaptation pathways. Our technical analysis showed that the benefits, measured in economic terms, of flood protection for the Norfolk Broads far exceeded the benefits of protecting the cliffs. Although this evidence reinforced the decision that had been made, importantly, it also provided an economic argument to open up discussions on compensating clifftop homeowners. Of course, it is not, and never should be, all about money. You can't capture the value of home and community in an engineering model, which is why the involvement of the interdisciplinary team from Tyndall was so important. I use this example in my lectures today. It is a microcosm of many current and future climate change challenges. 3 lessons in particular from here resonate through every piece of work I have done since. First, there are trade-offs in managing different climate change risks. These are inevitable and will become more so as budgets are further stretched. The second lesson is that engineering choices do not just impact upon local communities. They have a long-term influence, and this can be over a far wider area than just their construction footprint. Finally, engineers, planners or politicians should not just march in with a predetermined course of action. People must be central to tackling climate change. They must be given time to understand, and ultimately they must own and help create solutions. This takes time, resources, creativity, and must draw upon a range of skills, but ultimately this will lead to more acceptable and sustainable outcomes. This work led me to appreciate quite how important engineers are to tackling big global challenges, to protect our coastlines, make our cities and infrastructure more resilient to extreme weather, and reduce the energy we consume. Yet whilst the role of scientists and policymakers was increasingly well recognised, civil engineers were woefully underrepresented. Their importance had not yet been recognised in the United Nations Intergovernmental Panel on Climate Change process. For example, in the 4th assessment report that was published in 2007, the section on utilities and infrastructure covers less than half a page of a 2,800-page report. I am pleased to say that this is no longer the case, and I will be one of the co-authors of an entire chapter on cities and infrastructure in the forthcoming 6th assessment report in 2021. In fairness, though, I think the engineering community was not quick to realise the importance of their role. As a researcher, though, this provided an exciting opportunity to think about how to assess the risks of climate change on the built environment and how to embed climate change into engineering design. And so began a new chapter in my career. Over the last 15 years, I've had the opportunity to work on a number of projects, looking at future flood risk to the whole country, understanding the impacts of climate change on our electricity and transport networks, and assessing trade-offs and choices in the planning of future cities. Recently, I chaired the infrastructure section of the UK's 2017 Climate Change Risk Assessment. This work highlighted how the country's infrastructure is already vulnerable to extreme weather events, especially flooding. Recent events have highlighted how our increasingly interconnected infrastructure is posing new challenges for engineers to grapple with. We often don't appreciate that until these services are taken away. For example, in early December 2015, an electricity substation in Lancaster was flooded, leaving the entire city without electricity for over 24 hours. This in turn quickly led to loss of internet, mobile phones, bank card transactions, lifts and petrol pumps. Just after Christmas in the same year, the River Ouse flooded York. In addition to flooding many homes and businesses, the flood damaged communications infrastructure, which not only caused local disruption, but also affected emergency services on Tyneside, 100 kilometres away. The increased interaction and reach of our road, rail, telecommunication infrastructures has created new risks which we only partially understand. Over the years, I've had the pleasure of working with many inspiring researchers, engineers and policymakers who have helped me make my work better, more relevant to society and accelerate new ideas and approaches into practice. This collaborative approach to innovation is absolutely crucial to tackling climate change. However, not everyone has been in agreement. From taxi drivers to CEOs, I have had to make the case for tackling climate change. Reflecting back on many of these discussions, people have often confused the question of whether greenhouse gases are altering our climate with the debate on if and how we respond to climate change. The science that links carbon dioxide and other greenhouse gases to climate change was established in the 1800s. The scale and timeframes of climate change continue to be the subject of intense scientific scrutiny. But unfortunately, it has also been used to undermine actions and sow doubt about whether we should be making any long-term investments to manage risks to people in the economy at all. There is much to be positive about, though. The last 2 decades have seen a major shift in our awareness of climate change. Research programmes such as the Newcastle Urban Observatory are deploying hundreds of smart sensors across the city to understand how its infrastructure responds to climate and other long-term changes. Engineers are increasingly well equipped for the challenge. Political will is evidenced in the UK's Climate Change Act, and most of the world has signed up to the Paris Agreement to limit greenhouse gas emissions. The UK's National Infrastructure Commission was recently created to look at long-term needs of our national infrastructure. Insurers and developers are starting to influence change. For example, earlier this year, Legal & General wrote an open letter to all engineering institutions calling for a revolutionary change into how we design and implement and create our built environment. However, many challenges still remain. I think one of the biggest for civil engineers is the inertia of our constructions. What, where and how we construct our buildings and infrastructure influences climate change risks and greenhouse gas emissions for decades, even centuries to come. Roads first laid by the Romans are still routes today. The Great Fire of London or Hurricane Sandy did not lead to London and New York being rebuilt along entirely different lines. How then, I often get asked, is it possible to prepare cities for climate change? Anybody who's visited Amsterdam recently may find it difficult to imagine that in the 1970s the Netherlands was not a haven for cyclists. Over several decades, through a multidisciplinary combination of legislation, planning and infrastructure, cycling became safer and more appealing. Now over a quarter of all journeys in the country are by bike, even more in the cities. As engineers, we need to get better at embedding this sort of ambitious, long-term thinking into everything we do. First, we must appreciate that each building and project is a piece of a much larger jigsaw. As a society, we need to collectively figure out what our vision of the future is. What do we want the picture on that jigsaw to be? Each new construction and every refurbishment of a house, road or bridge then becomes an opportunity to piece by piece transition towards the climate-ready cities and infrastructure that will see us well into the 22nd century.
Climate Change and Me was presented by Richard Dawson, and the producer was Alex Mansfield.